Hi, welcome to this page of the notes. What we're going to do here now is we're going to begin to work on that second objective or learning target. You should already now be comfortable, or at least have a little bit of a refresher on how you go from a verbal expression to an algebraic expression and vice versa, an algebraic expression to a verbal expression. What we're going to begin to look at here now on this page of the notes is just a review from Algebra 1 of solving equations and some of the properties of equality that we use to help us do that. Just quickly run through these here with you. The first one is the reflexive property. The reflexive property just simply means that any number is equal to itself. Pick any number you want, that number will always be equal to itself. The next one is the symmetric property. This is the property that allows us to flip things from one side of the equal sign to the other. Just real quick, make a note here. If you have x is equal to y, the symmetric property says you can write that as y is equal to x. Right? Doesn't matter what order the variables are on, as long as you flip that entire equation, symmetric property says that's okay. They give you another example up here of that. A transitive property, we're not going to get into too much here in these notes. It'll show up a couple of times throughout the year. They do give you an example here of what the transitive property is. We'll worry about that a little bit more when we actually get to it. Take a second and read through it. It should refresh your memory on it, but we're really not going to deal with it too much here, so we'll wait and hold off on that one. And then finally, the substitution property. This one we use constantly, and we're going to get a little bit of practice here in the next problems, but here's all it means. If you have a variable inside of an equation and then somewhere later on I tell you what the variable is equal to, just substitute that into the equation. And we'll go ahead and practice that right here. What I'd like you to do is name the property illustrated by each of the statements, and this is exactly what we've got. I've given you an equation, 3a minus 4 is equal to b. I then tell you b is equal to a plus 17. Okay, well, let's see what happens here, all right? I have this equation, 3a minus 4 is equal to b. I have b is equal to a plus 17. Since you know what b is equal to, it's a plus 17, let's go ahead and throw that in for b. So this guy right here is going to get put in where b is. So I'm going to substitute b for what I know it's equal to, a plus 17, and I use the name of the property. I'm substituting what I know b is equal to. So over here where I had a b, I now have an a plus 17, and you have done substitution. Oh my goodness, my pen is not writing correctly. Oh, I'm missing my U. Start over. There we go. Wasn't quite sure if we were going to make it there for a second. So you've got the substitution property here for this one. Let's go ahead and take a look at the next one, see if we can figure out what property is being illustrated here. Switch colors, we'll go to red this time. What I've done is I've given you this equation, 2g minus h is equal to 62. I then tell you h is equal to 24, and then I've written my final statement. But before I do that, I've told you what h is equal to. So you're just going to simply take what you know h is equal to. I would throw that into the original equation where h is, and let's see, is that what I've given you as the final equation? Well, 2g, I had an h, but I know that h is 24, which I've substituted in, and that's all equal to 6. So that's exactly what I've done. I've simply taken the h, which I told you what it was equal to, substituted into the original equation. Once again, that time it worked a little better. Substitution once again. Let's go ahead and jump down here now to this last one, see what we've got going on here. So if minus 11a plus 2 is equal to a negative 3a, I then tell you negative 3a is equal to minus 11a plus 2. Hey, those are exactly the same equation. The only difference is I've taken the negative 3a, moved it to the right, and the minus 11a plus 2, I've taken it from the right-hand side and moved it to the left-hand side. Well, that is simply our symmetric property. Which simply says, right, you can take that equation, you can flip that equation perfectly okay. That concludes this page of the notes. Head on over to the next page. I'll meet you there.